Number 8 aluminum SER cable, when used as a branch circuit for an electric stove, must be derated to 60 amps. This derating is a critical safety measure to prevent overheating and potential fire hazards. The National Electrical Code, or NEC, specifically addresses the ampacity, which is the current carrying capacity of conductors, and the requirements for overcurrent protection. In this scenario, adhering to the NEC is paramount. The NEC Section 215.3 Bone provides the specific guidelines for feeder conductors, which are relevant because the SER cable is acting as a feeder to the appliance. This section outlines the requirements for the overcurrent protection of these conductors. The ampacity of a conductor, such as the number 8 aluminum SER cable, is determined by several factors, including the conductor material, its size, the insulation type, and the ambient temperature. Aluminum conductors generally have a lower ampacity than copper conductors of the same size. This is because aluminum has a higher resistance to electrical current flow than copper. This higher resistance results in more heat generation for a given current, which is why aluminum conductors require a larger size or derating to carry the same amount of current safely. The NEC provides tables that list allowable ampacities of various conductors based on these factors. It is essential to consult these tables to determine the correct ampacity for a given installation. When derating a conductor, you are essentially reducing its allowable ampacity to ensure that it does not exceed its temperature rating. Overheating conductors can degrade the insulation, leading to short circuits, ground faults, and fires. Derating is typically required when conductors are installed in conditions that reduce their ability to dissipate heat, such as when they are bundled together or installed to conduits in hot environments. In the case of the number 8 aluminum SER cable for an electric stove, the derating is specifically required to ensure that the cable is adequately protected by the overcurrent device, which is the circuit breaker. The 60 amp breaker serves as the overcurrent protection device for the number 8 aluminum SER cable. A circuit breaker is designed to trip or open the circuit when the current exceeds its rated value. This protects the conductors and the connected equipment from damage due to overloads or short circuits. Using a breaker larger than 60 amps with the number 8 aluminum SER cable would violate the NEC and create a significant safety hazard. If the current exceeds the cable's safe carrying capacity but is less than the breaker's rating, the cable could overheat without tripping the breaker, potentially leading to a fire. The installation of electrical wiring must comply with all applicable codes and regulations, including the NEC. This ensures that the electrical system is safe and reliable. Improper wiring can result in serious consequences, including electrical shocks, fires, and equipment damage. It is always recommended to consult with a qualified electrician to ensure that electrical work is performed correctly and in accordance with the NEC. An electrician can properly assess the specific conditions of the installation and determine the appropriate wire size, ampacity, and overcurrent protection for the circuit. Firstly, the selection of the correct conductor size and type is critical. The NEC specifies the allowable ampacities for different types of conductors based on their material, size, and insulation. Using a conductor that is too small for the intended load can result in overheating and potentially a fire. Secondly, the overcurrent protection device, such as a circuit breaker or fuse, must be sized appropriately to protect the conductor. The overcurrent protection device should not be larger than the conductor's ampacity. Thirdly, proper installation techniques are essential for ensuring the safe and reliable operation of the electrical system. This includes ensuring that all connections are tight and that the conductors are properly supported and protected from physical damage. The NEC is a comprehensive set of standards that covers all aspects of electrical installations. It is updated every 3 years to reflect changes in technology and best practices. It is important to stay current with the latest edition of the NEC to ensure that electrical work is performed in accordance with the most up-to-date standards. The NEC is adopted by many jurisdictions as the basis for their electrical codes. It is therefore essential to comply with the NEC to ensure that electrical installations are safe and legal. Understanding the NEC requirements for conductor ampacity and overcurrent protection is crucial for ensuring electrical safety. The derating of number 8 aluminum SER cable to 60 amps when used for an electric stove is a specific example of how the NEC protects against overheating and fire hazards. Always consult the NEC and a qualified electrician for guidance on electrical installations. This ensures a safe and compliant electrical system. It's important to remember that electrical work can be dangerous, and it should only be performed by qualified individuals who are familiar with the NEC and other applicable codes and regulations. Attempting to perform electrical work without the proper knowledge and experience can result in serious injury or death. The NEC provides detailed tables and guidelines for determining the ampacity of conductors under various conditions. These tables take into account factors such as the conductor material, size, insulation type, ambient temperature, and the number of conductors in a raceway or cable. It is important to consult these tables to determine the appropriate ampacity for a given installation. In addition to the ampacity tables, the NEC also contains requirements for derating conductors under certain conditions. Derating is required when conductors are installed in environments where their ability to dissipate heat is reduced, such as when they are bundled together or installed in conduits in hot environments. The NEC provides specific derating factors that must be applied in these situations. The overcurrent protection device, such as a circuit breaker or fuse, must be sized to protect the conductor from overloads and short circuits. The overcurrent protection device should not be larger than the conductor's ampacity. If the overcurrent protection device is too large, it may not trip in the event of an overload or short circuit, which could result in the conductor overheating and potentially causing a fire. The NEC also contains requirements for the type of overcurrent protection device that must be used in different applications. For example, certain types of equipment may require the use of a specific type of circuit breaker or fuse. Proper installation techniques are essential for ensuring the safe and reliable operation of an electrical system. This includes ensuring that all connections are tight and that the conductors are properly supported and protected from physical damage. Loose connections can cause arcing, which can generate heat and potentially start a fire. Conductors should also be properly supported to prevent them from sagging or rubbing against other objects, which could damage the insulation and create a safety hazard. The NEC provides detailed requirements for the installation of electrical wiring, including the types of materials that can be used, the methods of installation, and the spacing requirements for conductors and equipment. In summary, the derating of number 8 aluminum SER cable to 60 amps for an electric stove is a critical safety measure that is required by the NEC. This derating ensures that the cable is adequately protected by the overcurrent device and that it will not overheat under normal operating conditions. Always consult the NEC and a qualified electrician for guidance on electrical installations. The proper selection of conductor size, overcurrent protection, and installation techniques are essential for ensuring the safe and reliable operation of an electrical system. Furthermore, remember that electrical codes and standards are in place to protect people and property from the hazards associated with electricity. Compliance with these codes and standards is essential for ensuring a safe electrical environment. Ignoring or neglecting these requirements can have serious consequences. The electric stove is a significant electrical load in a home, and its wiring must be carefully considered. The heating elements draw a substantial amount of current, and the wiring must be able to handle this current without overheating. The number 8 aluminum SER cable is a common choice for electric stove circuits, but it is essential to understand its limitations and the requirements for derating. The derating factor is applied to account for the fact that aluminum has a higher resistance than copper, and therefore generates more heat for the same amount of current. This is why a smaller aluminum conductor must be derated to a lower ampacity than a copper conductor of the same size. The National Electrical Code is the primary source of information for electrical safety in the United States. It is a comprehensive document that covers all aspects of electrical installations, from the selection of wiring and equipment to the methods of installation and maintenance. The NEC is updated every 3 years to reflect changes in technology and best practices. It is essential for electricians, contractors, and anyone involved in electrical work to be familiar with the NEC and to comply with its requirements. The NEC is not a law itself, but it is often adopted by state and local governments as the basis for their electrical codes. This means that compliance with the NEC is often legally required. When working with electricity, safety should always be the top priority. Electrical shocks can be fatal, and electrical fires can cause significant damage. It is essential to take all necessary precautions to protect yourself and others from electrical hazards. This includes wearing appropriate personal protective equipment, such as insulated gloves and safety glasses, and following all safety procedures. Never work on electrical equipment that is energized unless you are qualified and authorized to do so. Always disconnect the power before working on electrical equipment and use a voltage tester to verify that the power is off. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician before performing any electrical work. An electrician can assess the specific conditions of your installation and provide you with the best advice on how to ensure that your electrical system is safe and compliant. The NEC is a complex document, and it can be difficult to understand all of its requirements. An electrician can help you navigate the NEC and ensure that your electrical work is performed in accordance with its provisions. Remember, electrical safety is not something to take lightly. It is essential to be informed, to be cautious, and to seek professional help when needed. Firstly, verify the specific NEC edition adopted in your jurisdiction. Electrical codes can vary by location, and it's important to adhere to the local regulations. Secondly, carefully examine the cable jacket for markings that indicate its type, size, and ampacity rating. This information is crucial for determining the correct derating factor. Thirdly, consider the ambient temperature in the area where the cable is installed. Higher ambient temperatures can further reduce the ampacity of the cable. The NEC provides tables for adjusting ampacity based on ambient temperature. Fourthly, if the cable is installed in a conduit or raceway with other conductors, apply the appropriate derating factors for multiple conductors in a raceway. The NEC specifies these derating factors based on the number of conductors. Fifthly, ensure that the circuit breaker is properly sized to protect the cable. The breaker should not exceed the derated ampacity of the cable. Sixthly, use a calibrated amp meter to measure the actual current draw of the electric stove under normal operating conditions. This will help you verify that the cable is not being overloaded. Seventhly, periodically inspect the cable and connections for any signs of overheating, such as discoloration or melting. If you notice any signs of overheating, immediately turn off the power to the circuit and consult with a qualified electrician. Eighthly, keep all electrical panels and equipment clear of obstructions. This will allow for proper ventilation and prevent overheating. Ninthly, consider upgrading the wiring to a larger size if the current draw of the electric stove is consistently close to the derated ampacity of the cable. A larger conductor will have a higher ampacity and will be less likely to overheat. Tenthly, if you are unsure about any aspect of the electrical installation, always consult with a qualified electrician. Electrical work can be dangerous, and it's best to leave it to the professionals. Electrical systems are designed to operate safely when installed and maintained properly. However, when electrical systems are not properly installed or maintained, they can pose a significant risk of electric shock, fire, and other hazards. It's important to be aware of these hazards and to take steps to mitigate them. Regular maintenance is essential for ensuring the safe and reliable operation of an electrical system. This includes inspecting wiring, connections, and equipment for any signs of damage or wear. Replace any damaged or worn components promptly. Keep electrical panels and equipment clean and free of dust and debris. Dust and debris can accumulate on electrical components and cause them to overheat. Periodically test ground fault circuit interrupters, or GFCIs, to ensure that they are functioning properly. GFCIs are designed to protect against electric shock by detecting ground faults and interrupting the flow of electricity. The NEC requires that all electrical work be performed in a neat and workmanlike manner. This means that wiring should be properly supported, connections should be tight, and equipment should be installed according to the manufacturer's instructions. Sloppy or careless electrical work can create safety hazards and increase the risk of electrical problems. When performing electrical work, it is important to use the right tools and materials. Using the wrong tools or materials can damage electrical components and create safety hazards. Always use tools that are designed for electrical work and that are in good condition. When working with electricity, it is important to be aware of the potential hazards and to take steps to protect yourself and others. Always disconnect the power before working on electrical equipment and use a voltage tester to verify that the power is off. Wear appropriate personal protective equipment, such as insulated gloves and safety glasses. Work in a well-lit area and avoid distractions. Never work on electrical equipment when you are tired or under the influence of drugs or alcohol. If you are unsure about any aspect of electrical work, always consult with a qualified electrician. Electrical safety is everyone's responsibility. By following these safety tips, you can help to prevent electrical accidents and injuries.